Hello, everyone. This is Simonovich. I lead the industrial cyber practice at Siemens Energy. Very glad to be here with you today, albeit virtually. A special thanks to the IoT Security Foundation and the opportunity to speak to all of you. We'll be talking today about cybersecurity, in particular industrial cyber, and how this emerging risk frontier has become the most critical issue for us to address as a means of enabling the energy transition, creating cleaner, more reliable energy, and defending the whole energy system in the new era of cyber threats. We'll be talking about the power of visibility to drive insights and action against emerging industrial cyber threats. I'll cover the megatrends. From there, I'll talk about the threat landscape, the readiness of energy companies, and we'll focus in particular on visibility, detection as the means to quantifying risk and getting ahead of attackers. So let's get to it. Where the energy industry is going. There's a revolution underway. On a call just a few weeks ago, Bernard Looney, the CEO of British Petroleum, made an announcement that BP was transitioning from being a pure play petroleum company to being an integrated energy company, one which will provide a reliable supply of energy no matter the fuel source, whether oil, gas, or renewables. That in fact, in this new energy world where climate change, reliability, there's a new energy system that's emerging that's increasingly dependent on digitalization. That is to say, the connectivity of assets to enable greater control, optimization of those assets, dispatch of energy where it's needed in real time, all with the ultimate goal of achieving a net zero world. To many, this announcement was a game changer because a major oil company was charting a new course for its future. If we zoom out, what we see is that digital revolution offers enormous promise. That promise comes with the opportunity to build new business models, to push power production and energy extraction to the edge, to increase connectivity, to make our assets smarter, and then, of course, focus on cleaner sources of energy to drive the energy transition. All of these macro drivers are bound by digitalization and the need to be connected in real time. With this increased connectivity, of course, comes an expanded attack surface. Every node could potentially become a pathway for bad actors to get in and then exploit the energy system, invisible, to cause a shutdown, or worse, a safety event. We've had a number of near misses. The first, of course, and the one that's most well known was the compressor station this year, which was shut down for 2 days. and then that ultimately cascaded out to shut down production. The second, last year, was the attack on petrochemical facility in Saudi Arabia, very close to the region and its needs. And then in the United States, the loss of visibility into power production to almost half the grid. What we're talking about here are operational technologies. These are your pipelines, refineries, wellheads, and power generation that's associated with it. This is the oxygen of our economy, and it is important that we keep it safe. And yet, what we've seen is an emergence of the new risk frontier. That frontier is industrial cyber. Not only is the frequency of attacks targeting critical infrastructure growing, but their sophistication. And the hard truth is this: the gap between defenders and attackers is expanding as the cost of malware goes down and as more digital assets, especially at the edge, come online. What that's enabling is almost a perfect storm. And we as the industry must find a way to deal with addressing both the physical world and the digital world. We at Siemens Energy have been thinking about the industrial cyber problem for well over a decade. And what we believe is the core challenge that needs to be solved is that of visibility. The basic premise being that you cannot protect what you cannot see. This is the only way we can measure risk, understand our vulnerabilities, and ultimately get ahead of attackers. And yet, only 18% of energy companies today are using any sort of artificial intelligence or machine learning for monitoring. Contrast that with the speed of attacks, and the imperative becomes clear. We need to get faster at detection. We need to get faster at understanding what's normal. We call that context. The understanding of the commands that are being sent in the digital world that will impact the physical world. Only with context and insights can we get to action and either contain or prevent attacks happening. What this is going to take is creating a unified view between the physical and the digital worlds. We need to not only understand the behavior of networks and digital flows, which can tell us whether something is abnormal, but also its physical world impacts. We need to replicate the physical world to answer the what if question, to understand what anomaly does to production, what asset is associated with it, where does that asset sit within the process flow, and then what its cascading effects will ultimately look like. We need a unified threat stream for data sets that were never designed to be looked at together until now. Traditional IT approaches have not worked. To get after the problem of visibility context in the operational technology world, we need a new way to think about detection. We need to understand how the physical world impacts the digital world. We need to model that in real time. We need technology that uses artificial intelligence and AI and machine learning to get us speed, scale, to support in-depth investigation, to help us understand what's happening and get after that deep context. And of course, we need a deep bench of expertise, of individuals that understand not only networks, but also understand the behavior of control systems, their configurations, and to understand how those commands are ultimately going to impact turbines or the flow of oil. Siemens Energy has built that unified view. We started by looking at methods. We call this patented approach process security analytics. And the big difference between that and traditional monitoring is the ability to generate in real time from billions of data points, from sensors in the physical world and from digital flows, a picture of what's happening. And then automate that at scale. The time to insights is really key. Speed is of the essence. And only with real-time modeling, we call it digital twin. An understanding of consequence and the multiple effects on production is the only way we're going to get our edge. And so, what we've built is managed detection and response, the first of a kind built for purpose monitoring solution for the industrial world, for energy assets. Its backbone is our EOS.II platform, which allows us to do investigations, build a topology of the physical world that allows us to go from the highest level of intelligence all the way down to the sensor to understand what's happening. We can visualize the digital twin of the physical world with our plant visualizer. That visualizer allows us to comprehend what's happening and understand those cascading effects, but also to build alerts or a set of plays, we call them playbooks, and rules that take decades of experience of Siemens Energy analysts to bring the logic of production and workflows, day shift versus night shift, logging into an offshore platform, bringing all of that back into a centralized view, and then enhancing that with the collection of data from all of our assets all over the world. What we found is that today's IT threat intelligence data is not that useful. It doesn't help us understand with all its indicators what is happening. We needed to build a way to understand the threats, the profiles of how a particular attack, say WannaCry, can impact a wellhead or a refinery. Our EOS platform allows us to automate and drive context, insights, But ultimately, we cannot take action without the power of human intelligence. And this is where we need to get better at tailoring our detection to the energy assets for the specific installation, but also for the fleet. The way that we protect a wind farm is going to be very different from the way that we protect a wellhead. And yet, the attackers know no boundaries. Given the interconnectivity between our assets, especially along corporate networks, and the convergence between information technology and operational technology, there is a scenario in which a malware can jump from IT into OT, can jump from a wind turbine to a wellhead. And so it is critically important that we tailor our detection to how these assets are run, but also zoom out and take a bird's eye view of the problem. This is why when we think about human intelligence, we break it down into three pieces: sharpening tools and algorithms. We have to get better at building rules and using machine learning in a way that is custom to the asset. We also have to get better at working through the pathway of attack, what is commonly known as a kill chain. And in operational technology, unlike IT, where there are a number of alerts, and many of those get resolved, it never actually become a breach. In the OT world, every alert matters. So we've built workflows that allow us to stay from an alert through the investigation. By putting on the perspective of the attacker, what would they do to attack our environment? That is a model in which our analysts handle the flow of attack from start to finish. This is where the industry needs to go. We need focus. And then ultimately, we need to act on this intelligence, but we need to do it in a way that is proportional. And so, proportionality and consequence are the name of the game. We call this precision defense. The mantra in operational technology detection should be, but is not currently today, do no harm. And that means that we need to take a rapid and proportionate response. Well, how do we go about doing that? We have to understand the consequence in the physical world. We have to understand three types of consequences, in fact. The first, of course, is operational. Pulling the plug, and like IT environments, doesn't work. It's very, very costly to stop production. Is there a better way to contain the threat? Prioritization by impact becomes really key. Operational impact, economic impact, and then of course riskiness. And equally important within this whole scheme, because we're talking about real world consequences, is safety and environmental integrity. So traditionally in security operation environments, the thought was to only look at alerts in a vacuum. We cannot do that any longer. we have to look at the HIC and the operational impacts on an equal footing. And then we need to work jointly between the OEM, like Siemens Energy, and all of you to take joint action. It may be our assets, but it's your operations, and we need to build common defenses to provide proportionate response and get to a resolution. This is the only way we're going to get faster and get ahead of attackers. And so, what we believe is in the power of artificial intelligence, the power of machine learning, and we'd welcome all of you to think about visibility as a core issue that needs to be solved in order for us to enable the energy transition, digitalization of our new energy system, and bring the advantage back to the defenders. Thank you very much, and look forward to your questions and a robust discussion.